Hello everyone, welcome to Master to Teach Step-by-Step Guide. In this video, we are going to learn what is the class diagram, how to find the required classes for the class diagram, what is association and type of association in the class diagram. We will go through step by step. We will learn what is aggregation, composition, inheritance in the class diagram and many more relationships with examples. I will try my best to explain step by step. If you haven't subscribed to our channel, please click on the subscribe button and subscribe to our YouTube channel. Okay, let's start. What is the class diagram? Class diagram is one of the important UML diagrams for software development, which shows the object classes in the system and the association between these classes. Simply, class diagram visualizes the object-oriented system. According to the Wikipedia, in software engineering, a class diagram in UML is a type of static structure diagram that describes the structure of the system by showing the system's classes, their attributes, operations or methods, and the relationships among objects. The class diagram is the main building block of object-oriented modeling. It is used for general conceptual modeling of the structure of the application and for detailed modeling translations the models into programming code. Class diagrams can also be used for data modeling. The classes in the class diagram represents both the main elements, interactions in the applications, and the classes to be programmed. The class diagram is a static type structure diagram that describes the structure of the system by showing the system's classes, each class's attributes and operations, and also the relationship among the objects. Various types of class diagrams may be produced at different stages of software development. At an early stage, a class diagram might give an overall picture without many details, whereas later on, the class diagram might have developed to reflect design issues. So, there will be much more information on it. Before jumping to the design, let me start from the reverse direction. Here is a simple class named as students where different attributes are defined. Attributes are the type of data items that objects of the classes will store. Attributes are also known as the variables, properties, or fields. Roll number, name, standard, and total marks are the attributes. As you can see, the type and the visibility or the signature of each variable is defined as ID as a private integer, roll number, name, and standard as public string, whereas total marks as a protected integer. Methods are defined within this class name as register student, get roll number. This is a simple code for defining a class with attributes and methods. To help the developer to code these kinds of coding through graphically is all about the class diagram. That means from the class diagram, the developer can easily start the coding as well as know the relationship between the classes of the system. The class diagram contains all the classes that needs to define while developing the system. We will learn how to retrieve the required classes of systems in a few minutes. Before that, let's learn how to represent the class in the class diagram. The class is represented by a rectangle box that contains 3 compartments. In the top compartment, we specify the class name. In the second or middle one, we specify the attributes, whereas the third or last one is for the showing the methods or operations. For example, student class. Class name as students. Attributes are ID, roll number, name, standard, total marks. We specify the data types as attributes followed by colon and the type. Here, ID, roll number, and total marks are integer. Name and standard are string. We can show the visibility or signature of the attributes as follows. Private is denoted by a single dash. Public is denoted by the plus sign. Protected is denoted by the hash sign, whereas package or default is denoted by this sign. Derive is denoted by the front slash. Static is denoted by the underline. The visibility defines the access right to the methods or operations of the classes. From the given table, it's clear about the access right for different visibility. Simple in the third compartment, we define the methods or operation like register students, get total marks. Here, arguments are name and standard, whose type is string. The return type of this method is boolean, which can show in the class diagram as :boolean, like this. Also, the visibility or signature can be specified similar to the second compartment. Here, register is public so that we denote it by the plus sign in front of the method name. List students, edit students, delete students are also the methods which we can define in the third compartment. In this way, we represent the class, its attributes and methods of the class in a single rectangle box. Okay, now let's learn how do we find the required classes in the system. So far, we have gone through the use case diagram, high-level use case description, expanded use case description. With the help of expanded use case description, we have drawn the collaboration diagrams, also known as communication diagrams, and we also derived the sequence diagrams. If you remember, while drawing the communication diagram, we learned how to find the domain classes of particular use cases. If you haven't gone through it, please find the link in the description below, or you can visit the YouTube channel Master to Teach and find the videos of it. Yeah, it's true. All the domain classes that we separate while drawing the communication diagrams are all the classes we need to draw in the class diagram. For the moment, we will concentrate on the domain classes. So, go through all the communication diagram for the system and list the domain classes. For example, let us take the same case study, college student record system, for which we drew the use case diagram, high level, and expanded use case description, communication and sequence diagram. List out all the use cases and domain classes of the respective use cases. From this use case and domain classes table, list out the unique domain classes like student, course, enrollment, and assessment, which are the needed domain classes to support the use cases. After the list of all the required domain classes, another most important in the class diagram is showing the relationship between the classes. Number 1, we find the unique domain classes from the use case, which are the main classes needed to define in the system. Number 2, draw the class diagram of each domain classes. At the earlier stage, we might leave out the attributes and methods, but we can add these later. Number 3, showing relationship. What are the different type of relationship between each classes? Number 1, association. If two classes exchange information in between or need to communicate with each other, then there must be a link in between them, which is modeled by association relationship. An association on the class diagram shows that the two classes might need to able to send message to each other. Association is represented by the solid line, like this. For example, let's see the student and course classes. The student chooses the desired course. The student and course classes will communicate or pass messages to each other so that these two classes have an association relationship. We will show with the solid line connected in between them. Other example like house and person, student and membership, student and teacher, airplane and passenger. Ways to find the association relationship. From the requirement, like a student will choose the desired course. That means there is an association between the student and course class. Many staff works under a manager. Here, staff and manager classes have an association. Another way to find the association is from the communication and sequence diagram. We can also find association relationship from the communication and sequence diagram if there is any message passing in between the objects of the classes. After the association relationship detection, we need to label the association relationship because it's not clear from the diagram what exactly associated between the classes, so that label the association relationship just above the line like student chooses courses. The manager has the staff. Even after the label on the association relationship, it's still confusing to understand the diagrams like courses chooses the student or student chooses the courses. The staff has a manager or manager has a staff. So that we place the small solid line with an arrowhead to guide the diagrams like this. This is read the diagram from this direction, like student choose the courses. Another important part of the class diagram is multiplicity, which is also known as cardinality. Wherever the association relationship, there must be the multiplicity. Different possible options and notation for the multiplicity are exactly 1, 0 or more, 1 or more, specified range, multiple disjoint, 1 or other. While specifying the multiplicity in association relationship, make sure to place in both classes, for example, student and course. We need to view from both directions. A student must enroll in at least one course. No student can join the college without choosing at least one course, and students can choose more than one course as well. Then we notify as 1 dot dot asterisk, which means must have at least one and can have more than one. From another direction, a course may have 0 students as well as many students. For example, a college starts a new course but no student has joined the course. Then we write multiplicity for 0 or more as 0 dot dot asterisk. In this way, we can show the multiplicity in every association relationship. Let's move further. Another type of relationship in the class diagram is aggregation. Aggregation is a special type of weaker whole-part association relationship between two classes where the part can exist separately from the whole. That is, if the whole class is deleted, the part will not be deleted and the part will remain to exist. Aggregation is represented by using a hollow diamond symbols pointed toward the whole class. For example, college and student, library and books, rooms and walls, employee list and employee, car and engine, hospital and doctor, computer and mouse, team and player. The life cycle of the team and player are not necessarily the same. The team may close down while the player may carry on with the another team as a player. Similarly, the computer may crash while the mouse can rejoin into another computer. Another type of relationship is composition. It is also a special type of whole-part relationship between two classes where the part cannot exist separately from the whole. Here, the relationship between the whole and part is tighter. The composition is represented by using a filled diamond symbol pointed towards the whole class. Composition relationship is also called as composite aggregation. Remember that an object can be part of any one composition at a time. For example, building and office, browser and tab, person and head, pound and fish, folder and files, etc. An office is part of a building. Here, the office can only be part of one building so that, as I mentioned you before, there can be only one composition at a time. An office building must have one or more offices, whereas the office must belong to one building only. The life cycle of the building will govern the life cycle of the office. If the building is knocked down, the offices will cease to exist. Similarly, if the browser is closed, then all the tab open or exist in that browser will auto-close. Let me give you a practical example. In the e-commerce system, if the user account is deleted, then his all cart items will also be deleted automatically. All these examples have a composition relationship, adding more feature in class diagram. I have mentioned before the association between the classes is represented by the solid line with no arrowhead on it. That means the message can flow on both directions. For example, manager and worker. Here is an association between these two classes, which is represented by a solid line without arrowhead. This reflects that the manager object and worker object both can flow messages to each other. In programming language, the manager object can use or call the worker attributes and methods which are non-private, and also the worker object can also use or call the manager attributes and methods which are non-private. What if we have to show that only manager can call or flow messages to worker, but worker can't flow messages to the manager? In this case, association between the classes is represented by the solid line with an line arrowhead pointed towards the class, from where that object can't flow message to another class object. Here, only the manager object can send the message to the worker object, means the message flow in only one way. Now need to know that in some aggregation relationship, messages can flow both ways, like team and player. Here, team and player objects can flow messages to each other. Whereas in some cases, team objects can only flow messages in a one-way direction. But in composition relationship, messages typically flow in only one direction from whole to part. Building and office. A building object can send message to the office object, but the office object can't. Moving forward in the class diagram, one of the most important representation in the class diagram is inheritance, which can be numbered as 40 steps as showing inheritance. As we all know, inheritance means showing the parents and child relationship, simply showing the types of some other class. If two classes have a parent-child relationship, then they have an inheritance relationship. Inheritance relationships between two classes represents similar to the use case generalization, where we draw the solid line with arrowhead pointed to the parent or superclass. For example, shape and circle, rectangle, employee and teacher, administrator, animal and animal name like lion, tiger. Here, shape is superclass, whereas circle and rectangle are subclasses. We represent inheritance in a solid line with an arrow from the child use case to parent class pointed the arrowhead towards the parent class. The main advantage of inheritance is we define all the common attributes of the child classes in the parent class, and all child class extends the parent class to use the required non-private attributes and operations. The child can have additional attributes and operations of its own as well. Let's see another example, employee and teacher administrator. Employee class define the basic or common attributes and methods needed for any employee like employee ID, employee name, start work method, leave method, etc. Teacher class extend employee class to take an attributes and methods of employee class, and also the teacher class adds some unique attributes and methods which is only used for it like teaching subject, change teaching subject method. Now for any teacher we can store the employee ID, employee name as well as teaching subject and can call start work, leave method as well. Similarly, another class administrator also inherit the attributes of the employee class. So in administrator class only define the unique attributes and methods which are not included in employee class like department, change department method. Same as teacher, administrator object can also hold the employee ID, employee name and department and can access the method, start work, leave method, etc. We can show the inheritance in this way as well. In inheritance, they are tightly coupled because a child class uses most of the parent's attributes and operations. Most of the cases, parent or superclass is defined as an abstract class whose object doesn't exist and its attributes and operation can only be used by its child classes. In this case, for the abstract class in the class diagrams, the class name is written in italic font or placed in between double greater than and less than sign as shown in the figure. Moving further in the class diagram, association class. As I had already mentioned you before, whenever there is relationship between two classes, we draw a line between two classes to show the association. Now, whenever there is an association, there might be an association class. If there need to provide additional information about the relationship between the classes, the association class is used. An association class is the class that is part of an association relationship between two other classes. An association class is particularly useful where there is a many-to-many relationship between the two classes. Let's take a simple example. Student can enroll in courses. Here, student and courses class have an association between them. An association class enrollment further defines the relationship between the student and course classes by providing section, grade, enroll date, semester information related to the association relationship. Note that enrollment hangs from the association between student and course by a dotted line without an arrowhead. One more relationship, that is dependency relationship. Dependency relationship do not have name, but it is the weakest relationship that exists between two classes if the changes to the definition of one may cause the change into the another, but not the vice versa. In programming, passing objects as an argument represents the dependency relationship, which means a class using another inside the method. For example, meeting and schedule class. If something changes in meeting, like meeting time changes, then it would affect the schedules as well. But if something changes in the schedule, it would not affect the meeting class. It is denoted by the dashes line with a line arrowhead. Another real-time example of dependency relationship is between the cart and product. In an e-commerce application, a cart class depends on the product class because the cart class uses the product class as a parameters for an add operations. In a class diagrams, a dependency relationship points from the cart class to the product class. All these additional relationships between classes may allow a more detailed models of the problem domain to be produced. However, it is usually best to keep the diagrams as simple as possible. Only add further information if it is really likely to be useful in understanding the requirements or producing a suitable design. I hope you learned from this video tutorial. If you have any question or comments, please make sure to leave a comment in the comment section below. Also, please be sure to like this video and subscribe to my channel if you haven't already. Thank you very much for watching. Check us out for more in IT tutorial and guide on website master2teach.com. And we will see you again soon. Bye.